Number 17A. Without looking at the ionization energy table that's in your textbook, arrange the following elements in order of decreasing first ionization energy. So first ionization energy, and it's got to be in decreasing order, meaning we're going to start with the largest and end with the smallest. So number 1 largest is going to be neon. Number 2 is going to be fluorine. Number 3 is going to be oxygen. Number 4 is going to be carbon. Number 5 is going to be lithium. And number 6 is going to be potassium. B, for each of the elements, which of the elements listed above would you expect to have the highest second ionization energy, and why? Well, I would expect lithium and potassium to have the highest second ionization energy because in both cases, in lithium and in potassium, the second electron must come from a completely filled noble gas electron configuration. Why? Because both lithium and potassium are in group 1, meaning they only have 1 valence electron. So once we've removed the first electron, right, by following the first ionization energy, we've removed that 1 electron, and we now have a noble gas electron configuration. To follow our second ionization energy, which is what this question is asking, we're going to have to remove a second electron. That second electron is going to shatter or ruin both of these atoms' noble gas electron configuration. Now, between these two, right? Oh, and by the way, you definitely don't want to ruin a noble gas electron configuration because that's when it's the most stable, and it's going to take the most energy to upset that electron configuration. So that's why that second ionization energy is so high for these two elements. Now, between these two elements, of the two, lithium would have the higher second ionization energy because the lithium ion is smaller than the potassium ion. And what does that have to do with anything? When you are smaller, when your electron cloud is smaller, that means that objects that come into contact with that atom, by the time they reach the edge of your electron cloud, they are actually closer to the nucleus. Because there aren't as many electron shells. If there aren't as many electron shells, you can get closer and closer to the nucleus. Meaning if you're a smaller atom, other objects can get closer to your nucleus. And remember, with electrostatic attraction, the closer you are to that object, to the source of your electrostatic attraction, the stronger that force is going to be. And if, in this case, with regard to ionization energy, if the hold on those electrons is greater, that's a higher ionization energy. So the lithium +1 ion is smaller, meaning the valence electrons are closer to the nucleus, meaning they experience more electrostatic attraction and are therefore held more tightly. And if they're held more tightly, they have a larger second ionization energy.